two point-like objects of masses 20 grams and 30 grams, as shown here, are fixed to the two ends of a rigid massless rod of length 10 centimeter. That means this entire length is 10 centimeter. This system is suspended vertically from a rigid ceiling as shown, using a thin wire attached to its center of mass. Center of mass, important thing. Where is the center of mass? Here is the center of mass. How to calculate? Now let's say here this is 10. Let's consider the origin here. If I consider the origin here, this is the origin, and let's say this is equal to x, then how much is the remaining distance? The remaining distance is 10 minus x. That means we can consider the origin at the center of mass. If we do that, if we consider origin here, let's say this much is x, then this much will be 10 minus x. Now center of mass calculation, x of the center of mass is equal to 30 into x minus 10, because this is to the left side, plus 20 into plus x by 30 plus 20, that is 50 grams each. The x of the center of mass is equal to how much? 3 by 5 into x minus 10 plus 2 by 5 into x. 3 plus 2, 5. 3x plus 2, 5x means this is simply x minus 30 by 5. 30 by 5, that is 6. X minus 6. This is the center of mass position. Now what is x then equal to? If this is equal to 0, because if center of mass is considered at origin, then x is equal to 6. Now how about that? X equal to 6 means this length is 6. This is 6 centimeters, and therefore this is simply 4 centimeters. Your center of mass is located. Now this system is suspended from its rigidly using a thin wire from its center of mass. The resulting torsional pendulum undergoes small oscillations like this. The torsional constant is given as this, 1.2 into 10 power minus 8. 1.2 into 10 power minus 8 is given as the torsional constant. Angular frequency of oscillation. Angular frequency of oscillation means 2 pi by capital T is given as n into 10 power minus 3. Let's start solving this question for now. Now see dear, your time period of oscillation is for a torsional pendulum in this case. And for a torsional pendulum, the time period is always given as 2 pi root over I by k, where I is the moment of inertia. Now, moment of inertia of this system can be easily calculated. Considering this as the origin, you are at a distance of r1 this side, r2 this side for two masses. Let's say this is mass of m2. Let's say this is the mass of m1. Let's say this is equal to r2. Let's say this is equal to r1. That means this is going to be m1 r1 square plus m2 r2 square. Once we have this, we can replace this. Then we can go for calculating the angular frequency as equal to 2 pi by capital T. Let's begin with moment of inertia. Now m1 is equal to 30 grams. So this value 30 grams means 30 into 10 power minus 3 into r1 square. r1 square means 16 into 10 power minus 4 plus m2 is 20 grams, that is this, into r2 square, that is 36 into 10 power minus 4. So therefore we are going to have 480 plus 720 into 10 power minus 7. This makes it approximately 500 plus 700, 1200. That means 12 into 10 power minus 5, if I'm not wrong. This is 500 plus 700, 1200 means 12 into 10 power minus 5. This is 1.2 into 10 power how much? This is 1.2 into 10 power minus 4. This is the moment of inertia in kilogram meter square. Let's put it for time period. Let's calculate the time period of torsional oscillation, and therefore T is equal to 2 pi into root over of 1.2 into 10 power minus 4 here into k value. This k is equal to 1.2 into 10 power minus 8. So therefore this is 2 pi into root over of 10 power 4. This is going to be 10 power 4 means 2 pi into 10 power 2. That means this is going to be approximately 200 pi. The time period of torsional oscillation is going to be 200 pi. Now, therefore, your omega value is going to be 2 pi by 200 pi. Therefore, this is simply 1 by 100, that is 10 power minus 2. Now, if you talk in terms of 10 power minus 3, then we are saying 10 into 10 power minus 3. This gives us simple n is equal to 10 as the answer of this question, which belongs to JEE Advanced 2023. Thank you for your patience. See you in the next question. All the best. And stay subscribed, stay revised.